Is it this one?
Yep. You just plug it in there.
There we go. And all right, procedural generation with wave function collapse. Turn it on. There we go. All right. Can you quickly play the video?
Yes.
This is going to be an explanation of the algorithm, the specific implementation that we used in Starlight, our game. Click no, that's malware.
What was on that mouse?
This is just a visualization of how the algorithm actually works in scene.
Let me skip ahead to the...
Yeah, you can skip ahead. Right now, every single blue tile, I'm not sure if it's easy to see in the far back, blue on blue, but the way algorithm works is it goes tile by tile, checking to see if tiles conflict within a certain array, and just sort of removes tiles procedurally as the level generates, placing them down one by one until finally you get a finished room. We can just sort of, click off of that.
Yeah,
That's the wrong one.
No, it's, yeah.
I'm sorry.
It's okay.
What is wave function collapse? This is the definition that Google gives you. It is not important. It doesn't matter, right? Here's my step to absolute development hell, because that is what our generator looked like majority of the first semester. To start off with, we're going to start off with just a 2D representation of wave function collapse. Tiles. It is the entirety of how wave function works. It is all defined on rules, tiles, fitting them together, right? The way we developed it is using a key socket system, identifying 2 IDs per face of each tile. Oops, I went too far. Oh, can you go back one?
Yes.
Is
that it?
One more, please.
There we go.
Yeah, there we go. Yeah. 2 keys. Why do we need 2 keys? So each face associated with it. I'm sorry, I'm not allowed to touch the screen, or
No, you are.
I'm allowed. Okay,
Yeah.
just on accident. Each face has a key and a socket associated with it. You might ask, why not use just one key, one ID? In certain cases, you want to identify specific interactions with each tile. Let's say staircases, right? It doesn't make sense to have a staircase that goes down and then immediately back up, right? Kind of creating like this zigzag pattern, right? Using 2 keys or 2 IDs, we can pair them together to create specific combinations that allow us to control which tiles fit together and which ones don't. Again, defining the rules. So let's start. Let's place a tile. Hey, tile. Now what? Let's look at the grid, right? We need to visualize what this actually looks like so we can understand what goes into a grid. All right, here's a grid slot. What is it? It is effectively an array or a list, depending on if you're using Unity or on Unreal. Doesn't matter. It contains every single possible tile that can potentially spawn in that grid slot, right? And I mean every single tile that's possible, variations included. So this is what it really looks like. You have your spawned tile and every single possible tile possibly surround it. Next, let's look to one side, right? We have our generated tile and our slot. Right now, what we want to do is remove any tiles that don't fit with this one face. So looking here, I'm not sure if it's easy for people in the back to see, but we want to remove any tile that doesn't have a door connecting to the left tile here, right? And so how do we do that? Simple for each loop, right? For each tile in this slot, compare it to that door. If it doesn't fit, remove it. Easy enough, right? If it does fit, keep it, leave it. We're going to move on, right? Until we get something like this, right? We removed all the tiles that don't fit. Any one of these tiles, if they were to spawn, will fit with that tile perfectly. All right, one more step. We look to its neighbors, right? So now that we have something like this, obviously, not all of these slots will have tiles that fit with the possibilities of this tile. So what do? Do it again. It's another for each loop within a for each loop. For each tile, loopception. There's a joke on another slide. Yeah.
Oh,
Not
sorry.
Even. No, you ruined my joke, but I'm more than
stole your
happy.
joke, man.
No, you're learning. You got it, right? For each tile, we want to compare each tile in this one to see if any of these fit. If there's a tile in this slot that cannot fit with any tile in the slot that we're checking, we have to remove it, right? Loopception. Thank you so much. And we just keep going. It's a recursive algorithm, so one tile to the next tile to the next tile to the next tile, and we keep going until chain ends, right? When does it end? Yeah, go ahead.
Sorry, one thing that is bugging my mind right now, wouldn't this be really like CPU heavy? If you're like the bigger, like,
Yeah.
you grow like, if you have like a 4x4 and then you have a 5x5, you're like slowly growing up, wouldn't be more and more heavy because you have to do this for over and over and over again?
Yes.
Yes.
I'll get to that later.
Ah,
There is a small bit, yeah,
Thank
but good question. When does it stop? When we stop updating a tile, right? So if we do not remove a single tile from this slot, nothing's changed. We know for a fact that any future tiles aren't going to change either, right? So why keep checking? It's done, right? So, oh, and while we're checking, this is important to realize. Hello, let you in here. What happens when we only have one tile left? We're checking, and suddenly we only have one tile left in a slot. Place it. That simple, right? It exists. Nice. So once we're done checking, once we've removed all the tiles that conflict with the tile we placed, we're left with something like this. And now we place another tile. Ideally, we want to place it where there are the fewest possible options. That way we can, I want to say for stability,
Yeah, I believe it.
probability-wise, like if you try placing a tile up here, it's likely something will conflict. So the reason we do it, place it here, least likely something's not going to go wrong. Ideally, if you define your tiles correctly, it should be fine. And we repeat this until, yippee, we place enough tiles to create a level, right? So, final notes about this algorithm. It doesn't have to be squares. It can be cubes, it can be triangles, anything that tiles, right? So long as you can define each side and track which, like the coordinate slot of where each tile is, you can make this work, right? Get weird with it. You can have weird octagonal tiles so long as you know and understand which faces correspond to which tile. If you can read that, define how that works, you can get wave function webs to do something with this sort of tile set. Another important thing, developer and designer tools. This is something really important. Why are you making procedural generation in the first place? It's because you don't want to do it. Make the computer do it for you, right? Make it as easy as possible for yourself, right? Look at these guys. Remember them? The computer can do that for you. You don't have to rotate them yourself manually, add them all. You just have to create 3 tiles and let the computer do the rest. What's that? 9 times 4? 36. Out of 3 tiles. This is an example that we have from our game. This is how I developed it in Unreal Engine. This is our implementation. It is just an actor class that I created as a child. It's a copy-paste for my team, which didn't use it. Blaming you. Kidding. But I tried making it as easy as possible to make tiles for them, right? So here's a big blow-up of what it looks like inside the editor. Top right, you have your data values. So your tile variations. So if there are different types of tiles that fit within the same key, right? So same door location, same floor location, same wall. If you have variations on that same tile, you can place them in here, right? Going down here, tile ports. So it is named a little bit differently here in this screenshot than it is inside the presentation, but we have the key and socket IDs, so one for each side. You can kind of see how they all appear down below and a little bit to the left. Fill them out right here. That's defined as your keys and ports, right? Really easy. You have your probability. So if you wanted, like mentioned before, if you want to make a tile more common than others, so for example, walls, doors, floors. If you want larger rooms, you would probably make open spaces more common than walls, right? And other than that, yeah. Here's the optimization thing. Here's what I didn't do. Because it's all in. Hello, welcome. You want to come in? Anything? No? Okay.
Yes. Have a seat, dude.
Have a seat, yeah, go ahead. do everything in C++.
Yes.
Blueprints is very limited.
Yes.
It is intended by namesake to be a blueprint. It is meant to prototype. I ran into difficulties trying to figure out a way to multi-thread it. I didn't find a way. And I ran out of time. So we ended up with, if you remember the video, it was slowly snaking around, checking each tile by tile. Very slow.
Yeah.
And that was only like, what, 30 by 30 by 30, I think?
Something like
Something like that, yeah. Make it in C++. You can take advantage of the GPU. Because it's a for each loop. It's a recursive operation that's happening over and over. It's recursive. It's the same thing. Multi-thread it, multitask it. Get like thousands of operations going a second with the GPU. Like, it'll go much faster than what I did. Because mine was single core bound. That thing was slow.
Get an AMD EPIC server CPU.
No, he's on something. Look. All right. And do as I say, not as I do. This is all right. This is generally well commented. Like, you have your intro, like on begin play. You have your debug tile set, which I think is down here. You have your if statement to tell you if. Right, generally well commented. You can read this. Right. Most of you, if you were given the opportunity, would look at this and say, "Okay, I can see where this is going." What about this? Not so bad.
oh, they're overlapping.
Yeah, right here.
Where's the
Look at that.
spaghetti? Where's the real spaghetti, man?
Real? No, you haven't seen nothing yet.
No, I have worked with Unreal. I know the spaghetti gets. Where is it? I want.
You want to get to it? All right. I'll tell you right now. This is for our loading bar.
Oh, no.
This, too blurry. I can't read that. I don't know what that is for. I cannot tell you for the life of me. This, I have no hope of telling you.
No.
You didn't find mine, did you?
Huh?
You didn't find mine, did you?
No, this is mine. This is only mine.
I'm saying,
Okay.
This is a roast B section, not roast D. I wouldn't do that to you. That is it. Do as I say, not as I do. Comment your code. Otherwise, you end up with that, and it makes your life so much harder. The whole point of ProcJet is to make life easy for you.
Yeah.
And that did not make my life easy. That's me. I'm done. That's wave function collapse in a nutshell.
Yes.
If you want to move on, go for it.
Yes, thank you, Dan. Thank you.
Thank you.